I was reviewing my mortgage today, and I know that my house payments are $560.10. I also know that I have a 3.125% APY interest rate, and I took out a 30-year loan. That got me wondering, what was the initial value of the loan? I could not remember. So I was thinking to myself, the HP15C would have made this problem really easy to figure out. You simply enter the payment amount, enter your interest rate, your number of terms, your future value, and it will calculate the present value, or what the initial value of the loan was. If you enter any four of these values into the calculator, it can calculate the unknown value. So that got me thinking, I wish I could calculate this on my MG15C HP15C Emulator calculator. And sure enough, there is a program in the Advanced Functions Handbook published by HP that walks through a program for the 15C calculator. It's on page 26 of the Advanced Functions Handbook, and it goes through and explains what each of the variables are. It shows where this particular program will be useful. And then it goes through the actual program itself. So line by line, we see all the program bytes. I've already programmed it, so I'm not going to painstakingly put in all 108 lines of this program in the calculator right now. Some things that may be interesting, though, because we can see all of our memory registers below the calculator. They're hidden behind me right now. N goes into R1, I goes into R2, the PV into R3, the payment into R4, and the future value, or FV, into R5. And it does show some of the other labels and registers that are used in the program. Now, one thing to remember is that my emulator does not require us to reserve the memory registries. It uses all of them for memory already. We do need to remember to activate user mode, and we should clear the registry just so we don't get any unintended values. Flag 0 is going to be set or turned off. It's going to be cleared, actually, for the payment at the end of the period, as it would be for a mortgage. And then here are the steps to enter the values that we do know. So we know N, we know I. We're looking for the present value, which was essentially the initial value in this case. We'll enter the payment, and then we're going to have 0 for the future value, because the loan will be paid off after the 30 years. So, to calculate the value that we're looking for, once we enter all our variables, we're going to press C and then RS. The link in the bottom of this YouTube video will take you to the calculator, and the other link will take you to the GitHub Repository. If you click on the Programs folder, Annuities and Compound Amounts, I have an instruction file. This is just a text file with the instructions. and then the JSON file that we can download to load into the calculator. So I'm going to download this JSON file. Alright, it went into my download folder. Now I'm going to go to the calculator, load JSON, and we're going to load the program for annuities and compound amounts. So we'll open that. And just to show you, if we go G program, we have 108 lines, and then this is our final return here. So get out of program mode. When I saved that file, I already put the calculator into user mode, so user mode is turned on now. I'm going to bring the manual back up and enter some of our variables here. So N is 30 years. However, the program takes it for each payment, so it's a monthly payment. So we have 30 years times 12 months per year is 360. Press A. Notice that the 360 went into R1, which was the memory register for the number of terms. My interest rate is 3.125% APY, so 3.125. However, we need to convert this to the monthly rate as well. So we can divide that by 12, and then we will press B, and notice how the interest rate is in memory register 2. The future value is already at 0 because the calculator was in a fresh state when we started. So we'll leave that alone. We're trying to solve for the present value, and we know what the payment is. So let's enter the payment. So the payment is $560.10. And because that money is coming out of my pocket and going away from me, we're going to change that to negative. And we will store that in D for payment. Notice down in our memory registers, our total number of terms is in R1. The interest rate is in R2. Our payment is in R4. It's negative because it's coming out of our pocket or away from me. The future value is 0, and we're going to calculate the present value or the initial value of the loan. So to do that, we press C. Now that loaded a value into memory register 3. However, the way the program is set up is we're going to press run stop, and then it's going to calculate the actual value there. So the initial value of the loan was $130,749.79. Now let's say we want to purchase a $300,000 house today. Interest rate's about 6% APY. We'll take a 30-year loan, and the house we want to purchase is $300,000. We can go to the calculator and enter 360 for A, which is N, the number of terms, and then 6%, 12 divided is 0.5, B for our interest rate, 300,000. We'll keep this positive because that's money coming to us. Will be C for the present value. We're going to calculate D for the payment, and our future value is 0 for E. And I'm using the shortcut keys here. Now we want to calculate the payment. So if we buy a $300,000 house or take out a $300,000 loan, interest rate of 6% APY, 30 years, we press D and then run stop. Our monthly payment will be $1,798.65. What if we want to make that payment $1,500? How much of a down payment would we have to make on the house? So we will put in 1,500, change sign, and then this is going into our payment. So this was A, B, C, and D. So we can press D. Changes our payment memory register. And now we're going to calculate C for our present value or the initial loan value. So we press C. Notice it puts that in there. However, we're going to overwrite that when we calculate. So run stop. Our present value needs to be $250,187.42. We can enter our $300,000 total purchase price. We're going to do XY subtract to get a down payment of $49,812.58. Now we could take this even further and say, okay, if I can afford to pay $1,500 a month for a home, maybe you're already paying $1,000 for rent somewhere, and you can save $500 a month, and you get a high interest rate savings account. You can now take that value and plug it in to see how long it would take you to save up that amount. I'll save you from that for now. And that is how we can run the annuities and compound amounts found in the HP15C Advanced Function Handbook on the MG15C RPN calculator emulator. Thanks for watching. I hope you appreciated it. I don't mind the likes and subscribes, but it's just a hobby. Thanks. Goodbye.